Hello everyone. Now we are going to the AutoGate and design using Autodesk Inventor. First, open the software. As you can see, the new assembly, new drawing, and new presentation and new part. As we are going to the gate train assembly, select on the new assembly. After opening the environment, first we have to go to the tools section and document settings and change the units length to millimeters and mass to kilograms. Press OK. As we are going to draw the assembly, save the file as assembly1. And in the Autodesk Inventor, the parts are ready-madely available, so the values are taken as module as 5, center distance as 150, and number of teeth for the gate 1 as 20 and gate 2 as 40, as it is a 2:1 gate ratio, and face width as 50 mm for both the gates. And we can change the power transmitted by the gates given as 2.5 kilowatts and speed as 150 rpm, and press calculate and press OK. And the gates of our required dimensions are available. Now design of gate shafts. As it is available on the desktop, and here different cylinders are present. Press OK according to the lengths given, and the shaft for the larger gate is present. Press OK. Now we are going to constrain the gauge shafts with the gauge above. For that, go to the assembly and use the constraint option. And for the construction, you have to select two faces. First one, the gear axis, shaft axis, and the gear axis as it is Z axis. Press apply. Use the same process for the small shaft and the small gear also. As the axis is fixed for both the gears, they are moving in the axis, but they are not fixed to the gears. For it, we must constrain them. Before constraining, let's make the gear shaft to fix at a middle position of the gears. For it, I am taking the offset as 30 for both the shafts with the gear. The shaft and gates are finished. Now design of keys. It is available in the design ribbon. Press the key option and we must select the faces for the key to design. First face on the cylinder or surface of the shaft as shown, and the second reference point as the face of the cylinder, and the third hub groove reference 1 and reference 2 as shown. Press OK. Similarly, you can see that the key is designed for the similarly we are going to draw it for the small gear. Same procedure. Take the reference of the cylinder face as shown and the reference to as cylindric and the hub groove as shown. As you see, the key formed is smaller than the hub, so we can adjust the length of the key as shown. By dragging the right arrows, we can increase the length of the key, and the left one we can adjust the key, and the center one as the angle of the key. You can see both the keys are designed. Now design of bearings. Bearings are available in the same design ribbon. Click on the bearing and we must choose the reference points. First one, cylindrical face as shown, and second one and the flip cover as 18 to 22 as shown, and select all ball bearing and choose a bearing as shown, that is JISB 1521. And after arranging the bearing to the shaft, press OK. You can see that the bearing is assigned to the shaft of the smaller gear. Now we must put the bearings for the remaining side of the shafts, that is for the larger gear and the other side of the smaller gear. For that we must copy the bearing and paste it according to your convenience. And now we must use the constraint option for constraining the bearings to the shafts. Use the first reference point of the constraint, the cylindrical shaft and the inner race of the bearing. use as you see, the bearing must not touch it to the shaft. There must be a clearance so that there is no friction produced. Use the same procedure for the constraining of the remaining bearings as shown. Inner race of the bearing and the surface of the cylindrical shaft. And now the design of bearing housing. As it is a new part, we will take as it is drawing new assembly, and we are going to take a standard part as it is one of the part of the drawing. Create. As the environment, you can see that the part 1 and the assembly 1, in which the gears and the bearings are present, and the part 1 where we are going to draw the bearing housing. Select a rectangle and draw a random rectangle using the dimension. Length as 400 mm, breadth as 150 mm. Create two circles randomly on the length of the rectangle and add first center of the circle in the side of the rectangle a distance of 175 mm, and the distance between both the centers of the circles are 150 mm. As the distance between the two gear centers is 150, we are going to make the distance as 150, as the bearings must sit on the housing that is provided now. Trim the unwanted portion as shown and select finish sketch. Now extrude the housing using symmetric option. Make the distance as 20 mm and press OK. We can make the fillet for the edge of the housing. As the fillet is only 2 mm, it is not appearing on the part. Let's make it 10. It is small fillet absorbed. You can see hit the arrow. Now 15 and apply. Close. Save the file for the further use. As take a file name as we are going to use and select again. Go to the assembly and In the place option, select the housing which we have created and open. Adjust the housing according to the assembly of the gear. As you see, the bearings are going to sit on the faces of the housing. We use constraint options for it. We must select two selections. The first one as the face of the housing and the face of the bearing. Select properly. As you see, the housing is constrained to the bearing. Use the same procedure for the remaining bearings also. As you see, first select the face of the housing and next the bearing face. One side of the housing is constrained to the bearings of the big gear and small gear. Use the same procedure for the other side of the housing. First select the face of the housing. As you see, the design of gate trends and housings are finished, and we must see that the housings are grounded so that they are not rotated, and make the gates as flexible and disable the grounded option so that they can rotate on a axis. We can change the appearance of the gates and shafts so as to look convenient. I'm going to change the color of the gates first. As the color changes, the material of the gates is also changes in the appearance. Uh, just to show the motion of the gates, I'm making different colors for the different parts. The color for the gear and the shaft and the gear 1 and gear 2, and the color for the housing. As the shafts and gates are in the same color, I'm going to change the color of the shafts. and the color of the bearings. As you see, the assembly of gate train using Autodesk Inventor is finished. As we rotate the larger gear, the smaller gear also rotates. Created the 2:1 gate train. The 2 revolution of smaller gear is equals to 1 revolution of the larger gear. Thank you guys for watching.